Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating article debunking a common misconception in computer graphics: the supposed inefficiency of conditional branching in shaders. Get ready, because this is going to be a technical deep dive.
I'm eager to hear this. I've always wondered about optimization strategies in shader programming. What's the core issue the article addresses?
The article tackles a widespread belief that using ternary operators, or if statements in shaders, creates performance bottlenecks due to branching. The author argues this is completely wrong for modern GPUs.
Interesting. So how does the author demonstrate this?
The author uses a specific example: a snap45 function that uses ternary operators to select different vector outputs based on input values. The optimization proposed by some replaces these with step, functions, and weighted sums, supposedly avoiding branching.
I see. And the author shows that this optimization is actually slower?
Exactly. The author points out that the step function itself uses a ternary operation internally. So, the optimized version adds unnecessary calculations, multiplications, and additions, without actually eliminating the conditional logic. The original code, using ternary operators, or if statements, directly performs a conditional move, which is a single, efficient instruction.
So it's not about branching at all, but about efficient instruction selection?
Precisely. The GPU handles conditional moves using a simple combinational circuit. A conditional move, not a branch instruction that alters the instruction pointer. The author even provides assembly code from AMD and Microsoft compilers to back this up. Both compilers show conditional moves, not branches.
That's compelling evidence. So what's the takeaway for shader programmers? Should we just ignore these optimizations?
Absolutely. The article strongly advises against these optimizations that replace ternary operators, or if statements with step, functions, and weighted sums. They often introduce unnecessary overhead and reduce performance. The author emphasizes that this misconception has persisted for over 20 years, spanning multiple GPU generations.
Wow, 20 years! That's a long time for a false optimization to persist. It highlights the importance of understanding the underlying hardware. I mean, it's not just about writing code that works, but writing code that's efficient.
Exactly. And the author's analysis of the assembly code is crucial. It shows that the compiler is smart enough to optimize the conditional logic efficiently, rendering the proposed optimizations pointless and even detrimental. It's a great reminder to always profile and benchmark your code to avoid premature optimization.
Absolutely. Thanks for breaking this down. This is a really valuable insight for anyone working with shaders.
You're welcome. And remember, listeners, always question assumptions, especially when it comes to performance optimization. Understanding the underlying hardware is key to writing efficient and effective code. That's all for today's Tech Bytes and News. Thanks for tuning in, and have a great day.
Bye-bye.